Assalamualaikum and a very good day. In this video, I will show on the 5 steps that I already teach you before. These 5 general steps will be used to answer a question on phase diagram. Normally, when we have a phase diagram problem, we can solve the question by these 5 steps. The first step is we find the phase or phases present. The second step is we find the composition at that region. We either have C liquid, composition of liquid, or composition of solid, where I denote the solid with alpha in this case. And then the third step is we find the relative amount, where we get weight percentage of liquid or weight percentage of alpha. Once again, I denote solid as alpha. For the fourth step, we find the microstructure that occurs at that region. And the fifth step is we find the cooling curve if necessary. So now we can move to other questions so we can try to solve all these 5 steps. In this exercise, we need to determine the weight fraction on each phase in the copper 50% nickel alloy shown in figure below at 1400 degrees Celsius, 1300 degrees Celsius, and 1200 degrees Celsius. I will show you the composition and weight fraction at 1300 degrees Celsius because at this temperature and 50 weight percent nickel alloy, we have a combination of solid and liquid. So for this question, the first thing we do is we find the phase or phases present. What we need to do, we need to draw a straight line from 1300 degrees Celsius and a straight line for 50 weight percent of nickel until they meet each other. When we draw a straight line from 1300 and 50 weight percent of nickel, the intersection occurs over here. At the intersection, we can see the phases present is solid and liquid. So we write the phases present as solid solution plus liquid. The second step is we need to find the compositions. For the composition, we have C node or C original, and then we have composition of liquid and composition of solid solution. Before this, I use alpha, but for this case, the graph used solid solution SS, so I denote it as SS. The C node will be 50% of nickel. We also can write down the composition as 50% of copper. To find the composition of the liquid, we need to draw a straight line from the intersection until it meets the liquidus line over here. And then we draw the straight line from liquidus line until we get a value over here. So the value that we get is around 44% of nickel. To find the composition of solid solution, we draw a straight line from the intersection until we meet the solidus line, and then we draw down the line until the graph. So over here will be our composition of solid solution is around 57% of nickel. Please remember to draw straight line downward. I'm using a computer, so it's a bit hard for me to draw a straight line downward. So for the third step, we need to find the relative amount, or we call it as weight fraction as in the question. What we need to do, we must use the lever rule. To find weight fraction of liquid, we need to use the intersection line until solidus line divided with all the lines. So for this case, the length of this line will be CSS over here minus with intersection over here. So the CSS is 57% minus with the C naught at the intersection is 50% divided with the length over here is CSS 57 minus with 44%. For the weight percentage of liquid, we will get 54% of liquid in that region. To find weight percent or weight fraction of solid, we must use the intersection line until liquidus line. We follow the lever rule and divided with overall line. To get this short line, we need to use C naught minus CL. So we have 50% minus 44% divided with overall length is CSS minus CL. CSS is 57% minus CL 44%. So we get the answer is 46% of weight fraction solid solution. Now with the same example, we try to solve the fourth step, which is microstructure. For the fourth step, I will show you how to get the microstructure for 1400 degrees Celsius, 1300 degrees Celsius, and 1200 degrees Celsius at 50% of copper nickel alloy. At 1400 degrees Celsius and 50% of nickel, the phase over there is liquid. So the microstructure that we need to draw is, we can draw a circle and then we tag the inside as liquid. At 1300 degrees Celsius and 50% of nickel, we have liquid and solid solution. So we draw a circle and then we draw the nucleus for the solid solution. After that, we label the nucleus as solid solution and the white region as liquid. At 1200 degrees Celsius and 50% of nickel, we only have solid solution only. So the phase is SS. To draw the microstructure, we draw the circle. After that, we draw the grain boundaries. And then we label the grain boundaries. And we label the solid solution. Now we are going to look at the fifth step, which is the cooling curve. To draw cooling curve for 50% of copper nickel alloy, first we need to draw the straight line for 50% of copper nickel alloy. After that, we draw a horizontal line from liquidus line until the temperature exists, and then the solidus line until the temperature exists. We take the temperature, then we draw the axis of temperature versus time. At temperature axis, we have TL and T solid. Then we draw like the alloy cooling curve. After we draw the cooling curve line, we must label the region of liquid, solid plus liquid, and solid region. That's all for the 5 steps to solve phase diagram. If you don't understand, you can contact me later. Thank you. Have a safe and nice day.